You're saying the fourth class is? Has the person giving the name disappeared? Okay, your network, you guys, is poor. Okay, the fifth one is can I have the name for the fifth one?
Yes. Let me just try, sir.
Yes, Emmanuel.
Okay, so the fifth one is 3-methyl.
3.
Are you getting? Yes. And 2,5.
2.
2,5. Yes.
2,5.
Yes.
Okay.
Dioxoxane.
All right. The sixth molecule, can I have the name?
I'm just giving it a try, sir.
Oh, okay.
It's 1-chlor, 3-methyl, comma 3-methyl, comma 5-bromo, comma 7 nitroheptane.
Can I have the name for the seventh? The name for the seventh molecule. I should have given this one to Valen. Valen, are you in class? Or she's one of the people having problems with the network? Okay, so I think the last question I should have given it to Emmanuel upon arrival, right? Emmanuel, didn't I give you the last question?
Oh, I answered one of those, sir.
You answered the fifth one. All right. So
Yes, but 5.
I'll begin with the question that was supposed to be done by Aka. I was saying in the previous classes that we've had, I told you guys to say when you are doing nomenclature, check, does your molecule have a functional group? You've checked, you have 2 functional groups here. So you have an alkane functional group, and you also have an aldehyde functional group. This is an aldehyde because there is a hydrogen atom here. And remember, when we are doing bond line, we don't show hydrogen. So the hydrogen is missing there that is supposed to be there. So among them, these 2, which one has a higher priority? An alkane or an aldehyde? Of course, an aldehyde has a higher priority. Now, if you go and check on the, if you go and check on the priority table, you will find that if an aldehyde is acting as a suffix, what is going to happen is that you get the name of the alkane, you remove the last letter E, and then you replace it by AL to the name. So this is what you're going to do. Then after that, you've identified the highest priority functional group. meaning the functional group that will give a suffix. That's where your counting begins. Or close to that particular functional group is where your counting should begin. So my counting will begin on this particular carbon atom here. So this is my carbon 1, and then I have 2, 3, and 4. Okay, so this is a 4-membered carbon atom, but on position number 2, there is beginning a double bond. So what you're going to do is you have 2 options in the naming, and one of them, I'll make mention of it. You will write it yourselves. Then the other one I will give here. So what it is that since you've identified that the double bond is on position number 2, you can actually say 2-butanol. Okay, 2-butanol. Or you can begin the name but, then you do that, then 2, then this, then En. So this En represents a double bond. En represents a double bond. If the molecule was saturated, it is supposed to have An. Now, since it has a double bond, so it is going to have En. And then like that. Or here, you can do the same and do that. So this is optional. The putting of 1 there is optional because it's always for an aldehyde, it's going to be in position number 1. It is like a carboxylic acid. The carboxylic acid will always be on carbon number 1. So there's no need for you to show where it is. So you just saying like that is going to be fine. So the name is but2-enol. So it's but2-enol. Okay, so there's the enol at the end there. There's the enol at the end there. Or you can put the 2 in front and you just name it as butanol. So you know, naming it as butanol, the 2 that will be in front of this particular molecule will actually show that this molecule is what? It has a double bond on position number 2, and also the aldehyde on position number 1, because the aldehyde's position is not actually put in a molecule. So you have named this one. That's the ease with which you name. You come to molecule number 2. So molecule number 2, you check. You have 2 functional groups, an alkane and an alkyne. You again check which of these 2 has a higher priority. That's why I said the priority table, whether you like it or yes, you have to master it. It's non-optional. It's a must know. Okay. So what you're going to do is between these 2 functional groups, already have identified that an alkane has a higher priority than an alkyne on the priority table. An alkane comes before an alkyne. So therefore, an alkyne is a substituent, an alkane is not, so you begin counting. Counting from here, you have 1, 2, 3, 4, 5, 6. Okay, and counting from here, you have 1, 2. So the alkane functional group should have the lowest number, and it is on position number 2. So your counting should begin on top. You have 1, 2, 3, 4, 5, and that is a 6-membered molecule. So you're going to begin on position number 5. That is where your alkyne begins from. So you have 5, and then you call it as, so you have 5 ethanol, like that. Okay, 5 ethanol. So this is what actually shows ethine, not ethene. Yeah, this one, 5 ethanol, like that. Don't put ethyl. When you put ethyl, you're talking about something totally different. So it is ethanol. This is what is actually representing the Y there. The YN. The YN is what is representing the double bond. So it is 5 ethanyl, and then like I said, you can begin the naming of the molecule. So it is an hep or hex, since this function group is on position number 5 and it is an ethanyl itself, so your counting ends there. So it's 1, 2, 3, 4, 5. So it is eggs, and then 1, 2, like that, and N like that. So it is 2 ethanyl, 5 ethanyl eggs, 2N, like that. Or these 2 can actually come here and you just put it as 2-exam, meaning the double bond is on position number 2. So that is how your molecule was supposed to be named. When we come to this particular molecule here, I have, okay, so let me just move this name a bit there. Yeah, so the molecule is clear. So this particular molecule, again, you identified the functional group, giving it the suffix. You were right on that one. You had identified your functional group. And then let me see on your counting, you have 1, 2, 3, 4, 5, 6, 7. And 1, 2, 3, 4, 5, 6. So where your butane came from really was here. You did the counting starting from this point as 1, 2, 3, 4 for your butane, and then you put these as substituent. But that's not how the counting should be done. The counting should be done tail to tail or head to head. You begin from one end, you finish at one end. You don't start the counting in between. So you don't count starting. This is your in-between counting. That is why you're having 1, 1 there. So you will hardly have an alkane substituent on the N terminal. Okay, you will hardly have an alkane on the N on the terminal as a substituent. That's what I mean. All right, it's highly unlikely. So your counting needed to begin from here: 1, 2, 3, 4, 5, 6, 7, or 1, 2, 3, 4. So counting from this end gives this particular function group a high number. Counting from here gives it a lower number. So it's 1, 2, 3. That's why your group is 4, 5. So you have substituents on position 2 and 5. So in your naming, naming of this particular molecule, you needed to say 2, 5. Okay, that is 1, 2, 3, 4, 5. So 2, 5 dimethyl. And then on position number 3, that's where your hexane is. So this time I'll put it like that so that you also know that this is acceptable. And then we put heptine. Okay, heptine, like that. So your name needed to be like that: 1, 2, 3, 4, 5, 6, 7. So 2, 5 dimethyl 3 heptine. That is the name of your molecule. So this name actually goes up to your molecule. So let me do that, and then try to extend it like that, like that. Okay, so that is actually the name of your molecule. It's covering what I don't want it to cover. Okay, so basically you have seen how your molecule should have been named. When I bring it down a bit, it will cover that molecule which we need to name. So we move on to the fourth molecule. Again, the fourth molecule is the same as the second here. The same principle you have used to name here is the same principle you will employ in naming the molecule there. So I ain't doing question 4. I leave it for your practice. Since 4 and 2 are the same, there'll be no need for me to start repeating the same principle on this one. I come to question 5, which was yeah, so this one you try it out. And then we have question 5. So question 5, again, you check, you'll find that there are these 2 functional groups that are there. Then you ask yourself, are these 2 functional groups the same or different? They are actually the same. Now, every time you find a carbonyl molecule like this, then it is attached to an alkane functional group like that. This is a ketone. So you have a ketone here and you have a ketone there. You count from this end 1, 2, 3, 4, 5, 6. You count from this end 1, 2, 3. So counting from the right gives this substituent a smaller number, and counting from either end gives these substituents the same number. Therefore, since they are being given the same number, you count from the end that will give the other substituent a smaller number. So counting will begin from the right. Now, in the naming here, you had done your counting right. You began from the correct position. You had positioned the methyl group at the correct position. The only thing you did was you took the substituents as functional groups. I mean, you took the functional the functional groups as the substituents when they are actually the molecules of higher priority. That's the only error you made. So what you did is you got the suffix and you called them oxo. Yes, when ketones are substituents, we call them oxo. But in this particular instance, they are not substituent. Instead, they are the final molecules they are the final functional group giving this particular molecule a name. Therefore, your name should be a ketone. So it should end in non. So it is hexane. You've already put those positions there. So the name becomes hexane. Like that. And then dione. Why dione? Because you have, so this here, ONE is what is representing the ketone themselves. So what would have happened was I would have, if there was just one ketone, we wouldn't have added a di there, I would have just called it as hexanon. But there are 2 substituents. Don't make a mistake of putting the di before the name begins. The di is only for the functional group and not the molecule itself. So should you put a di before the name, if you put this di here, there before the name, it will mean 2 hexanons and not 1 single molecule. So again, careful with where you put these tri and di things. So yeah, that is how your name needed to come out. Or the other way would have been, you remove these from there, you start your name. When you reach here, you open it up like that, 2,5. And then you call it as a dione. So it is 3-methyl-hexane 2,5-dione, meaning 2 keto groups on position 2 and 5. So that is how that particular molecule is supposed to be named. So if you check, naming of organic molecules is actually very simple. Once you identify which of these functional groups is actually of higher priority, you are set. Okay, so I come to question 6. Again, I have 3 different substituents: a chlorine, a bromine, and a nitrile. Okay, no, a nitro. Now here, when you check your priority tables, again, it is straightforward on what is expected, right? When you have these functional groups present in your molecule, okay? When you have these functional groups present in your molecule, what you're going to do is you just check, and you will actually find that these functional groups do not give the molecules or they are not functional groups that attain suffix. In short, they are not functional groups that attain suffix. Okay, so what I mean is you can't really put them at the end of the name. Their effect will hardly be felt by doing that. So what you do is, just as the name has been given, it is going to be, these will be considered as substituents. So you count your substituents from this end is 1, 2, 3, 4, 5, 6, 7, 8. From there is 1, 2, 3, 4, 5, 6, 7, 8. So if you check the substituent counting from my left has lower numbers, 1, 2, 3, 4, yeah, 5, 6. So counting from my left have lower numbers. Okay, so the mistake made here is the same mistake that was made in this example here on question 3. So you were in the same line of thinking where you begin your counting on chlorine, that is inside counting. So you're beginning your counting from inside the molecule, which shouldn't be the case. The counting should begin from the end. So your counting should be here, not inside. So that is why you're having a 1 chloro there, because you've said this is your position number 1. And then 3 methyl. So again, it doesn't make sense to me how chlorine becomes the first position and then the methyl becomes the third position. What happened? How do you get those numbers? So that is highly unlikely. But anyhow, we have 1, 2, 3, 4, 5, 6, 7, 8. For you to have named it as a 10, your counting should have begun from there. So you had removed 1 end. That is why it is called F10. Otherwise, it is not F10. Then after you are done with the location of your numbers, you have known which end you are going to start with. I'm not starting from the right because it is skipping this number here. 1, 2, both left and right, the first substituent is on position number 2. But for the second substituent, when you check here, it's on position number 4, while here it's on position number 3. So meaning my second substituent counting from the left attains a smaller number. That is why your counting will begin from the left. So you begin from here, 1, 2, 3, 4, 5, 6, 7, 8. After you're done, then check now. These substituents, you have a chlorine, a bromine, a methyl, and a nitro. Which one comes first in the alphabet? That is the one that you put first in your naming. So in as much as you had identified the functional groups, their positioning was offset because you just positioned them according to numbers. But positioning is not according to numbers. Positioning is according to letters. Chlorine, bromine, methyl, nitro. The first one will be a bromine, and it is on position number 5. So your molecule is 5 bromo. And then you come to 2 chloro. Okay. You come to 2 chloro, and then from your 2 chloro, then 3 methyl. Okay, so 3 methyl. Now remember, in the nomenclature, you can identify the substituent. If you place them wrongly, you don't get any mark. We don't mark from identifying a molecule. No, we don't mark because you're going to give us the names of the substituent and then you give us a wrong name. No, you can identify the substituent correctly. You place them wrongly in terms of pressing them when naming. it's a wrong name because it is not going to follow the IUPAC laws, and therefore we will penalize you from that one. So please try to be as cautious as possible. Octane like that. So you have 5 bromo